quadrotors can carry a sling load to finish a wide range of tasks. However, a single quadrotor has limited payload capacities, largely limiting its operational range and endurance. In this work, we present an algorithm to coordinate and control multiple quadrotors to lift and manipulate the full pose of a cable-suspended load. With our algorithm, the quadrotors, together with the cable-suspended load, can even fly through narrow passages with high agility. In this process, the algorithm does not need to add any additional sensors to the load, offering high practicality. Our algorithm solves an online kinodynamic motion planning problem. Given a load reference trajectory in purple color, the planner generates predicted reference trajectories for each quadrotor in a receding horizon fashion to collaboratively execute the white-colored predicted payload trajectory. Meanwhile, the position and orientation of the load are precisely controlled in order to ensure collision-free traversal through the narrow passage, ultimately reaching the target pose. Our algorithm demonstrates the capability to accurately follow an agile trajectory with exceptional robustness. It can compensate for large external disturbances, such as a sloshing payload, and does not require an accurate model of the load's inertia properties, even when tracking agile trajectories. It can also effectively compensate for strong wind at over 5 meters per second, without the need to measure the wind force or establish any complex wind effect model. In conclusion, our method has greatly expanded the load capacities of aerial robots and opens the door to the next generation of scalable aerial manipulation solutions.